before we start to really do the simulation, we have to know where is the robot. So what I did in here was, so I have this table, right? So this table is exactly like that, only the dimension wise, not the whole box. So if you put a point in 0, 0, so you see this point, this is the origin of the robot.
Yeah.
Okay, so if I make a line, from here to here and execute the programs, and the robot moves from here to here, then it actually tosses the robot, the table's bottom. And another thing is, whenever we have a gripper, so if we see in the robot studio, so the robot's tip point is this one, right? So if we have a gripper, then this tip point will be moved to the down. So either easy way is just change this one, just use control, and then before I have to show you this one, that so okay here. So this is the position of the robot, so X, Y, Z, 0, and if I this is not the robot, this is the frame of the robot. So frame means here, down here, right? So if I change this one to, let's say, 500, then the whole robot will change. Did you just get that? Whole things got changed. Whatever in here, in this like the tree, everything got changed. So, and if I double click in this one, so this is the robot data, and in the data, this one is in. So if I change this value, so it is not changing. Why? Because I have to click on here. Now here, this is the gripper, and I can change the location of them.
Then, like, how about just adding the gripper to that?
Yes. So, what is the meaning of adding gripper there?
Adding the gripper to the robot arm here.
Yes, we can do that.
Yes.
And obviously, we're gonna do that. But the meaning, the gripper doesn't have any movement, right? It is just a fixed. It's just open and close. So the meaning of that is, so if we put the gripper, this point, the frame point, this will just move down.
Yes.
That's all.
Yeah, that's all.
So for now, when we are working, if we just put this the point down, then we can actually see if this is going with the flow or not, and then we can add the gripper, and anything is same.
Yes.
So
I think it's because just the table is flat, right?
yes,
Okay.
of course. So if I right click and here add tool, TCP, so you see this tool is it's nothing more than like same as the gripper, and when I click this tool, it says 200 mm is down from the main robot's points. So why does it matter? So now if I double click this and update, okay, it's good. I will teach you how to do this now. So if I double click this frame, you see that it is not actually moving from here, it is moving from here. Why? Because the gripper tip will be in here. So basically the main thing that we have to find out is how much far the gripper point from the robot's points. Then we can actually like assume that okay, this is the gripper point, and then we just add the like some virtual gripper and work. And after finalizing the simulation, if we want to record the real video, then we can put the gripper. Because we're not gonna open and close everything in here. We're gonna do on the real robot. So the main question is, so if we have any curve in here, how to execute that that one in the RoboDk. So let's suppose I make a curve in here, and if I put some already made curve, okay. So if we want to run the robot through this curve, so I just make that. If you want, I can make another one, like just for the time sake. So we can make the curve, and usually these curves are not what we made, is what we got, right? From the when we do the programming. Usually we don't do the simulations by the manual method. We use the Python code, and then through the Python code we get the path, and then that path will be used for the simulations, and that we learn later. So for now, if we have this kind of curve, okay, so instead of this, if we have this curve, and let's say it is a little up and a little back, and we can see how does it look like from the top, and little here. Okay, so so there is various way to import this curve to the RoboDk, and the RoboDk also give the plugin for the Rhino. So we're gonna use this one since it's easy. So we just select this curve. Before we do, let me delete the curve there's already in here. Okay, and this one is the curve. Okay, I don't have anything here, right? So for the whole things, you can actually visible or invisible, and whenever I don't have that, there is nothing. And we select the curve, and we say load curve, and we will have the curve here. So before we go here, let's see, in here there is a setting, right? So we can assign the name, the block name, whatever we write in here, we're gonna get there. And if we don't override, then there will be a new files every time. And so you can write everything in here, and then okay. And here auto setup means it will import everything that we have in the Rhino file. Automatically it will detect whether it is curve or plane or points. And then load part means we can select something, and then load part means it will load only those parts. And load curves is specifically load only the curves that we select, and the load points also import the points that we have. That's all in the plugin here. And then so in here, whenever we got the plugin, we get three things. The first one is the programming, the setting of the program, and the program itself, and the block. So this is the block. And first what we do is we open the programming, and usually we cannot get this update sign. So we need to find out. We just do update, and if this is correct, then that means okay, it can execute the curve. Sometimes it cannot execute the curve, then we have to manually do the things. So in here I will do this is operation speed per second 50. That means you remember yesterday when we did the default was 500, right? So here it is 50. So that's what you put. So I put default value is 50, so it always comes 50. But 50 is kind of slow if we do, so 100, let's suppose. It's not and joint curve tolerance, do you know what that means? Joint curve tolerance, can you guess? So let's suppose this is the curve, and the robot tip is this, and when it goes from here to here, the tolerance means how much far it can go from the curve while fulfilling the curve path. So if you say 0, then it's absolutely should go from the curve. So 0.5 mm is actually okay. That's 0.5 mm is nothing, so it's okay. And then here we can add normal means, so it says approach and retract, okay. In approach there is a normal in 100 mm. So let's say if I change that to 10, then you see here it got changed, it got smaller. So this is the added value on the curve, so that when before it actually go to the curve, the robot will go directly above to the curve, certain mm that we assign, and then go and then finish the curve, and then go again the retract value, and then go to the final EO position. So usually they just put 100, it is the default value, and it's not the only one value. So here is the tangent, so if you put tangent, it goes along that path, right? So I think there is also the, you can add the degree so that it can go slightly like side normal into tangent. So you can play with this, like the absolute real XYZ value. You can assign some XYZ value, and after the, before it goes to the curve, it goes on that position and then follow the curve. And actually you can add more than one, just add, and you will have the like a different kind of like the, if sometimes when you use the curve, then you need exact like the flow of the robot before you reach the curve, so that on that time we need those kind of things. So like when I cut the columns, I cannot just go and start the cutting the columns, right? Before cutting the columns there is still some styrofoam, so I need to go from like slowly curve upward and then again upward, so that it will not hit anything. So for now, and if you wanna delete, just like if you want to delete this one, you just say remove, in the top one will be removed, and then here is normal, okay. For now we will just add 100 and 100, and in here another one is select curve. So this is useful when you have more than one curve, and when you have more than one curve, then you can select, okay, robot first follow this curve and then this curve and then this curve, then it will go like that. But now we have only one curve, so this is not usable. Otherwise we can select curve, then we can select this, and then here done, and then we will have the curve. And then path point 109 means it actually divide the curve in 109 points, and it follow that. And if you really find the really want that accuracy, then from here to here it doesn't go curve way, it does just go straight, but eventually it looks curved. But you can, if you want, you have to change that. And path to the offset, this one comes handy sometimes when you really have like cutting the things and your tools are kind of like oriented in different way, or sometimes you use the XYZ value. Now it's okay. And so you have to play with this. And here this one is the configuration. So as I told him before, there are many configurations which you can select while it goes from here to one point to another point, and then you can select any, but the robot actually select the default one. Where what is the minimum configuration is where the robot doesn't have to move a lot and actually finish the work. So after that we just did update and simulate, and it goes right exactly. And the edit things is, since we finished this one, so let's say what we want is we want to go from here to here, and then here to here, and then after finishing this one, it will go from here to here and here to here. Let's suppose. So what I do is, first I need target 4, target 6. I think target 6 cannot be reached. So alt. Let's say we have this point. I think this is too high because of the tool points. Okay, new one. Target 6, and I'll just delete this. So I will say from target 6 go to the brick one, destination target 4. Okay, from target 6 I need to go to target 4, right? So I will select target 6 and target 4 and then create program. So I have a new program here, and this program give me direction from target 6 to target 4, target 6 to target 4, and its default value is 500 mm, so which you have to change. And for that I can just add instruction and so set speed and then 500, 100, or you can change anything, but higher the speed the more it will might cause the accident, so you need to be careful. And then we can rename that. Okay, start, and after this it will go here, and then when it finished it should go again target 4, and then from target 4 to destination. Let's say target 4 to destination. Okay, so I will select again target 4 and destination and create program. So there is a new program, join 5 crosses 0 degree. This is singularity. It's not allowed for a linear movement, so it's okay. I will change the linear to joint movement and try this again, so it's worked. And then what I do is from destination to target 4. That is not what I want. I want opposite, target 4, from target 4 to destination. Okay, so we can rename it end, and now we have many program, right? So how do we execute all of the programs in the single program? We can again select the new program. You can actually do on here, but for now what I just suggest, and this is the call program and program call. First I will do is select program. I will do the start one. Okay, and then I will have another, and I will have the program 2, right? You can edit the work, and then again I will call the end. Okay, so now if you, instead of all others, if you call this one, sorry, target 2, program 2, target is undefined. No. With this one it is B. This is the work. So let's work. So instead of here program 2, modify. This is not the right one. We should have work. Okay. So now we do. Yeah. So why this very fast was because we have the speed is very fast, so you can reduce and then again play. Okay, that is actually much reduced. Okay, it's coming from here to, it will come to here, and it will finish and then go to the another. So by this you can actually do, okay, first follow this curve, go to home first, and then follow this curve and then go to home. You can do that, and after that you know how to do that. Right click, then generate program. Right click, generate program.
Should he have to check if it if it may collision to the desk or something.
Okay. So that's why yes, of course we have
Yeah.
to check that. While seeing this, the robot is actually coming from up to down, so it probably is safe. So to see this visible, so we will have a 3D of the table, and we see how does it look like, and actually it's good actually, right? It's go from here, which is safe, out from the table. It goes up, go.
Are we able to? Oh, you said that we are not able to grip the block in RoboDk, right?
We can do the opening and closing, actually simulate it, but do you really want to do this in here, or do you want to do this in the robot?
Actually, of course we have to do that in robot, but I think we may have to do some simulation things in here.
Yeah,
to
of course.
like
That we can do later. There is a mechanism for this.
it's I was just wondering that we have to make the block higher, and like so
Yes.
it may collision with the block that we made. So I think we have to do some simulations in RoboDK before we do.
Yes, exactly. But you have everything in here. Like everything means you're gonna have the gripper here, and you're gonna have the actual blocks here. And when you see, actually you can eliminate the collision part for now here, and then watch the simulation, how it's going, and then do the work one time in the robot slowly, watching there.
Okay.
And then you wait. After the first time, you will find out that you can actually imagine this and the real robot. Okay, so I can imagine that this is the front part, so the robot will come like this and then go this way. Then I can imagine, okay, this is safe, then I can do the first part and then see if it is okay or not. Of course, everything can be done in here.
Okay.
And you can actually open the gripper, close the gripper, go actually take the block, like put the block in here, and then the robot will come, and we need to grab the block, and the block will be come with the robot, and then go and place on the desired place, and then it will leave the robot. Everything is possible. It's just a simulation, but that is for to make the understanding the other people's. So if you already understand, then you assume that okay, this command will open the gripper, then put this command, and then go there and then do the work.